Okay, let's talk about bit depth. Um, a bit, wow, I can't write very well. A bit is either a 0 or a 1. And in computer language, I'm sure you've heard of this sort of concept there. Each tiny little bit of information can either be on or off, and by stringing a bunch of bits together, you get bytes and megabytes and all that. But that's how it processes information. So the way that this corresponds with colors is by bit depth. And so if you had a 2-bit image, well, you've got, I'm going to write 2 here, which is how many possible combinations you have with 1 bit. You have either a 0 or a 1, so there's 2 options. If you have a 2-bit image, then you have a 2 to the power of 2, so you get 4 possible color combinations for each channel for RGB. If you have a 4-bit image, then you have 8 possible colors. If you have an 8-bit image, which is pretty common, then you have 256 possible colors in RGB. Then, if you go up from there, 16-bit image, then you've got, what was it, 65,536 possible colors in each channel. And then if you're just crazy, then you can have a 32-bit image, which is some insanely huge number that I don't even care to write down. But you are never going to come across this situation, because what happens is after 16 bits, you commonly go to what is called 32-bit float. So instead of having whole numbers like these are integers, then you have float, which introduces the idea of decimal points. And it also kind of resets the range. Basically, if you had an image in 8-bit that each RGB channel was 255, that would be white. You'd have a white pixel. And that value is 255 because it starts at 0. But what happens when you go to float is that instead of having a range that goes from 0 to 256, or in the 16-bit image would go 0 to 65,000 whatever, instead the scale is reset to 0 and 1. 1 is white, 0 is black, and then what's really interesting about floating point is that you can store values that are higher than white or even lower than black. So you could actually get a value that is 1.25 or even 7. You can get values that go way above and beyond, and all the information is stored inside that file. So this is all well and good and not very interesting, but let's go ahead and show you how that translates into your CG renders and why bit depth is important, what it allows you to do, and all of that. So let's go ahead and jump into Max. Alright, so here we are. We're back in 3D Studio, and I've got a very simple scene open up here. Just have 3 little teapots and a ground plane and this light here. The light has multiplier of 5 and it's using inverse square fall off. And we'll get to changing these values here in a second. But first of all, let's go ahead and render this and take a look at what we get. Alright, so nothing particularly interesting, but as you can see, the light just is falling off into darkness back here. And this is actually a 16-bit image. We know that because if we right-click and drag our mouse around, you see, I can't point to it, but the RGB values over there, the red, green, and blue under the pixel information, see how it says 1 divided by 65,535? Well, that's the 16-bit values that we were just talking about over in Photoshop. And as you can see, as I scroll around here, it's showing me what those values are under that pixel. And also next to it, you see there's the real numbers. The real numbers are kind of the floating point version of this, and that's why it's in decimals. Right now, I'm sampling a pixel that's 0.8, so it's not white. It's getting up there, but not quite there yet. So this is 16-bit. Now, if we were to save this out as a targa, let's just try, let's see, 8-bit TGA. Alright, actually, you know what? Now is a good time to look at this information right here. With the targa, you see you can have a choice of 16, 24, or 32 bits. This is not the same as what we were talking about before. This is telling you that there's a total of 32 bits when this file is saved out. What that means is that there's 8 bits for the red, green, blue, and alpha channel. So, 8 times 4, you get 32. If you don't have the alpha channel, it's 24. Now, normally when you're compositing, compositing programs deal with bits per channel, not total bits in the file. So don't let this confuse you. When you're talking about targas, and some other image formats do it as well, this number is talking about the total bits in the file. So this is going to be an 8-bit image that we just saved out. And what we can do is, since this is 16-bit, we'll just save a 16-bit version of this. We'll save it as a PNG, and that allows us to see 48-bit. That gives us 16 bits per channel. Alright, so if we go over to Digital Fusion, and we'll pull both of these images in, and we'll just take a look at them and turn that off. There's really visually no difference between these whatsoever, and that's actually to be expected. In fact, even if you rendered this in 32-bit floating point, you wouldn't see any difference at this point either. But let's go ahead and change our scene in Max a little bit so that you can see why having more bit depth is really beneficial, in some cases at least. Let's lower this to something really low. We'll go to 0.5 and we'll render this again. Alright, so you can see it's really dark now. You can just barely see, and out here it disappears almost. But you can see that we are getting some values in there in the 16-bit and in the float. So let's go ahead and save this out, and I'll just overwrite the ones that we have there. Alright, I'll save it out again. This time is 16-bit. Okay, and we'll go back, and I'm just going to force these to reload. Okay, so again, they don't look any different here, but watch what happens if we now brighten these up. Actually, I'm going to make an instance of that. Okay, so we'll connect each of these up, and we'll view this. So what I'll do is we'll just make this like 15, or actually we can go even brighter. Let's try 20. Alright, see what we're starting to get here? There's a lot of grain. This is due to having the lower bit depth. When you start pumping these values up, you'll notice that these pixels that were in there, they didn't have a lot of information stored with them. There isn't any depth there. Now if we did the same thing with a 16-bit image, it's nice and clean, and that's because there's so many more possible colors available that's saved out in 16-bit versus 8-bit. So this is something that's really beneficial if you know that you're going to be doing a lot of color corrections and changing the gains of your passes a lot. Then you might really want to consider rendering in a higher bit depth. Uh, Most of the time 16-bit is plenty. You don't need to go into floating point, but we'll do that next, and we'll show you the benefit of doing that as well. So let's jump back into Max and we'll render out some 32-bit files. Alright, so now what we're going to do is let's take this multiplier on our light and let's really crank it up. Let's just blow the scene right out. We'll do a render of that. And as you can see, we're very much blowing this area out. And what I'm going to do is I'll just save this as a 32-bit RPF file. So switch this to 32 floating point, say OK, and we'll go back in here, drop this in. Okay, and now you'll notice down at the very bottom of the screen, look right about here, when you mouse over, it tells you that the depth of that file is 32-bit. If we go over this, it says 16-bit int. That int int is integer, and that just means you're not dealing with real numbers. And this is an 8-bit integer, and this is 32-bit float. So we bring this in, and we take a look at it. And one thing that I want to point out is if you save to a floating point format out of, well, at least out of max 8, if you save it out of the frame buffer like I did, you're not actually saving the 32-bit information. This image is clamped, even though it says it's not. And the reason you'll know that is by lowering the gain. You can see that this is getting really flat and gray and looks really bad. That's unfortunately when you save out that way, it's clamping. And the reason is that the frame buffer here just, it doesn't show you the 32-bit information. So what we need to do to make it save it out properly is to actually set this and render it that way. So what we'll do is we'll just overwrite that file. Okay. Render again, yes. Okay, so go back in here and I'll just reload this pass. And there you see, what it's doing is when we lower the gain, we're actually changing the exposure of this shot. And all of that information that was rendered into here has values way up above 1. In fact, look right down, right down here. When I mouse over, you'll see that the RGB information there is 8.1. These are values above 1, so they're above white, and they're all stored in this file. So if we just bring the gain down on this pass, you're actually just adjusting the exposure. So that's really great. This allows you to change the lighting of your shots really easily. You have a lot of control over it without losing any of the detail. You could blow the scene out in your max file and not really worry about it because you can change it, although you shouldn't do that if you can help it. But one thing we should also look at is, alright, this one was rendered at with the multiplier of 50. This one was multiplier of 0.5. So if we were to bump this up to 100, we get the exact same results really. Now there is a slight difference if you look at the anti-aliasing, and that's just because of the difference that occurs with the different levels of contrast in the images when they were rendered. But this image is still only 16 bits. We're pumping it up way up above and making it look like this is the 32-bit render. But really, if we were to put another brightness contrast on after this and bring it back down, see we're losing that this image is clamped. However, we can still lower it here, and all the information is there because when we rendered the image, we weren't blowing anything out. If we had blown anything out, then we couldn't adjust it like we are now. But this is kind of nice because what you can do is if you render your passes and make sure that you never let anything clip to white, then you can actually do what's called floating point promotions and change this so that it behaves like a floating point file. What you can do is, even though you're loading a 16-bit integer, you can change it when you load it so that it's anything else. You can do float 32, float 16, 16-bit integer, 8-bit. So I'm going to change it to float 16. This is a floating point image that's using 16 bits. The only file format that you can save out right now that works in this is OpenEXR file, but in Fusion you have the option to work with float 16. So now if you notice down here at the bottom, when you mouse over it, it says the depth is 16-bit float. So now we can work in Fusion as though that's a floating point image, even though it's not, but it'll be processed like it is as it goes down the chain. Alright, so let's take a look at this image one more time, and you'll notice that the anti-aliasing on this just looks really bad, and it's actually, that's not the problem, because if we bring it back down by changing the gain down, the anti-aliasing is okay. The problem is when it's blown out this much that there's such a big contrast between the 0 black here and the extreme white here that it doesn't really know how to deal with such extremes. You can't really smooth that out, and when you're compositing there isn't really any solution for that other than to maybe add a slight glow or blur the edges, blur your entire frame a little bit. There isn't a great way to deal with that. So just be aware that if you are going to use floating point and you're going to blow things out, that you're going to need to figure out a way for your shot to deal with these kind of problems if they come up. So what bit depth should you use on your projects? Well, it really just depends on what you want to have control over in the comp. Or how you want to work in the comp also. With the 8-bit image, you're going to be able to do quite a bit with that, really. And it's going to be a lot faster than having a 16-bit or 32-bit file. So most of the time I would try and stick with an 8-bit image if you can. Sometimes when you're dealing with really smooth gradients like in a sky, or even if your textures just have smooth gradients in them, and you end up doing a lot of color correction, you'll start getting like banding problems. You'll see where there just isn't enough information and it starts to create, well, you don't see banding here, but you start seeing really harsh edges where it's changing from one value to the next value, and it just doesn't have any information in between, so it looks like it's stepping. In that sort of situation, then you might want to start using a 16-bit image. I see that kind of thing a lot with well, gradients, but also with atmospheric passes like fogs and smoke and things like that. Anywhere where there's smooth gradients, you'll start to benefit from having 16-bit. So if you're going to do a lot of color correction, go to 16-bit. Alright, I've jumped back into Max because there's one more thing that I want you to be aware of if you're going to work with floating point images. What I've done is I've animated this teapot just sliding over, and I put image motion blur on him, and I'm going to go ahead and turn on the save checkbox, and I'm going to overwrite our 32-bit image. So render that. And here comes the motion blur. Okay, so it's been motion blurred. We checked the alpha, motion blurred, and this image was saved out. So we'll go back into Fusion, and I'm going to reload that image. And if we look at it, okay, look what's going on. We actually don't have the image motion blur in this file. The alpha has it, RGB does not. And any floating point image that you save out as is going to have this problem. You can't use image motion blur with floating point. So you're going to have to use either 3D motion blur with a different renderer, or you can use the multipass camera motion blur. But unfortunately, no image motion blur. So make sure you are aware of that.